Hello, Mr. Kate again, and I'm going to go over the Chapter 9 commentary to the notes that I was looking for. So this is going to be the first of the two videos. So on this first slide here, all I want you to do is put in that one word or so that means what this dash means between ADP and P, or between H and O, or in between any two letters that form a molecule. What does the dash mean? On this slide 2, you're to write a summary of what's going on here. And the easiest way to do that is just read the first question up there. What is cell respiration? And it basically is breaking down food particles or food molecules into usable ATP energy. Okay. On slide 3, this slide is really useful because it tells you what happens where. In other words, glycolysis happens in the cytoplasm. Krebs cycle, or the citric acid cycle, happens in the mitochondria. And the electron transport system, or the ETC, happens in the mitochondria also. On the right-hand side, it does break down how much or how many ATP are made at any one particular area. So I want you to write a summary about that on the right side here or at the bottom also. Okay, so basically, how much ATP is made by glycolysis? How much is made in the Krebs cycle? How much is generated in the ETC? Okay. On this fourth slide, it's just a matter of dragging and dropping these words in. So you would literally click on the word. You want the cursor to change into that X or plus sign with arrows. Left mouse button, hold it, drag it, and drop it. Okay? Or same thing here, drag it and drop it. All right, so make sure you get these things in the correct order. You do not need to write a summary for this particular slide. Just need to drag and drop those words in position. Same thing with this one here, but you just have a 50-50 shot at it. So this process is aerobic, or is this process anaerobic that does not require oxygen? And I know I'm clicking right along here. Slide 6. This is the slide that has all kinds of stuff going on in here. And what do I want you to know about this slide? Yes, I do want you to know something about it. But I don't need you to know all about fructose 6-phosphate or fructose 1,6 bisphosphate. I don't need you to know any of this. What I need you to know is there are more steps than just going from glucose, break apart, got 2-pyruvate. There's several steps and all of this stuff going on to get to the 2-pyruvates. Okay, so your summary should state that the breakdown of glucose has intermediate steps that will eventually end up with 2-pyruvate molecules. Okay, slide 7. Slide 7, again, anytime you see a white box inside the actual slide itself, I want you to put your answer there. And slide 7 is, what is the difference between ADP and ATP? Adenosine diphosphate and adenosine triphosphate. Di means 2, tri means 3. There's your difference. Okay, difference between 2 phosphates and 3 phosphates. Also, you can look at it from an energy standpoint. ADP is like a battery that's only got half a charge on it. ATP would be like a fully charged battery. Okay, this slide here, I do want you to put in just the number of carbons that are in the various molecules in question. So it says, how many carbons are in one molecule of glucose? Well, just count them up. Okay. Same thing with how many carbons are in 2 pyruvate molecules? Well, you've got these 3 here, and you got these 3 here that are in 2 pyruvate. I'll let you do the math. Okay, just make sure you get 2 pyruvate. It didn't ask you for a pyruvate molecule. It asked for 2. Okay, and glycolysis, with this one here, this is supposed to be in terms of money. And I did this in a Jamboard before. So I may pause it here and I'll put up that Jamboard real quick. Okay, here I'm at the Jamboard. The math behind this, I asked you guys to put it in terms of 1 ATP equals $10. And so this is actually in dollar amounts here, where I have 2 ATP, that'll be the $20, and you got to spend $20 to get $40. So over here's the 4 ATP. So 2 ATP will make 4 ATP. $20 will make $40. So I spend another $20, that nets me out $20, but then I'm going to yield another $40. So that'd be 20 plus the 40 will be 60. Spend another $20, and that should be a minus here. So spend another $20, and now net me out 40 plus 40. So I'll get 80. So you can see I keep building up. Every time I spend 20, I get another extra 20 in return. And so every time I go through this cycle, I add another $20 to it. Okay, so I'll return back now to the notes and we'll continue on. Okay, so you can see there's where we're at. And so what do you put in here? You can put what I put on the Jamboard here, although it's kind of hard to do that. What you need to say is that for every turn or exchange or process, you're going to gain $20 per exchange or per event. So your bank will, so to speak, will increase by $20 every time you make the transaction. Okay, which is a pretty good deal. I wish my bank did that with my money. I would do that all day long. Okay, so next slide. Next slide, if you unbury these things over here, you can see all the intermediates. I didn't have them buried. I had them buried to begin with because I didn't want you guys focused on the intermediates. Again, I don't really care if you know about these intermediates or not, other than they're there. So if you want to have them covered up, that's fine. I did have a comment already made in the sample notebook, and it's over here where it says steps of glycolysis show that the generation of ATP and NADH molecules, and that's what this is depicting, where you go from a glucose molecule, you're breaking it apart, you're going through several intermediate steps, and as you are manipulating, breaking these steps down and apart, peeling off hydrogen ions, you're releasing energy, which makes ATP, or which is used to make ATP. It doesn't automatically make ATP. Okay. This one here, what happens in the mitochondria? Again, I said, go back up to slide 3, and you can see glycolysis happens in the cytoplasm, where in the mitochondria, you have the Krebs cycle, and you have the electron transport system, which are happening. So that's basically all you need to put is Krebs cycle is producing the NADHs and FADH2s and some ATP and sending that to the electron transport system, which is going to make a great deal of ATP. Okay. Then we're down to this one here. This is slide 12. Intermediate step in glycolysis, and it goes through with the Acetyl-Coa, where it's combining acetic acid and coenzyme A, or CoA. And you combine those two together, and that's an enzyme that couples with pyruvic, with the pruvates to manipulate their shape and to then carry them across the membranes of the mitochondria. So what is the function of an enzyme? Well, there's 3 of them. To break apart molecules, to build up molecules, or to manipulate the molecules so that they have a different function. Okay, that's what an enzyme does. All right. And this guy here, glycolysis, again, you can go back to page 3 and check that out. And it's just a drag and drop. So you would click on one of these numbers and drag and drop it over. Okay. put that back to there. And the last slide on this video is a summary slide. Read down through this thing. You're going to create your summary here on the right, or again, you can put it at the bottom. This thing here is talking about produces more ATP and releases more electrons. All of this stuff is picked up by the NAD pluses and the FADs, which are your energy carriers that are going to take all of that energy and ship it to the ETC, which is where it's going to be really used to its fullest to make all kinds of ATP. All right, hope that was a little helpful. I know it was really fast, but it's a video, so you can pause it. All right, and stay tuned for the second video, which will continue on from slides 15 all the way through to the end. All right.